Good morning, class. Welcome back. In this lesson, we're going to learn about perfect squares. It's nothing different from what you have been doing. It's just a specialty. I want you to observe that is taking place every time you do factoring. Pay attention closely. Now, a perfect square is when you factor a trinomial or quadratic expression with three terms, and when you do that, you get the same expression in both parentheses. You get the exact same thing in both parentheses as you have been doing. An example of what I'm talking about: consider x squared plus 4x plus 4. If you were to factor this, you know you have your two parentheses. You know the two signs going to be plus. But inside the parentheses, notice that you have x plus 2 and x plus 2. Because they are the same expression, we call it perfect squared. And it can be rewritten in the form x plus 2 quantity squared. See? This is what a perfect square is. Nothing more. Now, let us look at another example. This one with a leading coefficient greater than 1. Ladies and gentlemen, we have to factor it. We follow the same procedure. Your two parentheses with plus sign because both signs are plus in this case. And look at what we have. 2x plus 7 and 2x plus 7. Ladies and gentlemen, this is a perfect square. And it can be rewritten 2x plus 7 quantity squared. Now, let us look at this one. Ladies and gentlemen, if we follow the rules, nothing changed. We know we're going to have our two parentheses, and since the last sign is plus and the first sign is minus, we know the two signs are going to be minus. And we have 3p minus 5, 3p minus 5. And of course, this is a perfect square because it's the same thing twice. And we can write it 3p minus 5 quantity squared. That's it, ladies and gentlemen. That's what a perfect square is. You know how to factor already. It's just that factor it, you get the same expression, and you can write it as one expression quantity squared. Alright? Now, let us look at what we call difference of squares. Difference of squares is literally a perfect square minus a perfect square, where the term is a perfect square, not looking at the expression we just had here, okay? Do not confuse the two. Now, more elaboration will take place as you see this. It should come clear to you. Let's look at this. When you have the difference of squares, when factored, you get the same terms in both parentheses, the exact same terms, except the operating sign is not the same. You know, perfect square, everything is the same in both parentheses. Now, in difference of squares, the terms are the same, except the sign in between the terms are different. Here's what I am talking about. Let's look at this one right here. This is funny, isn't it? Now, difference of squares has two terms. Alright? And I know you know how to factor three terms, trinomial, that are quadratic. Fine. So, let's make it look like something we know. Even if it looks like this, so we rewrite it. Now, that's better. It looks like what we have been doing, doesn't it? Now, all we have to do is factor like we've been doing, except that we need parentheses. And notice that, ladies and gentlemen, since our sign is plus and minus here, we know for a fact inside the parentheses we're going to have a plus and minus. So we don't have to worry about anything really. And we end up with x plus 5, x minus 5. That's it. That is a difference of squared factored, because now you get the same terms with different signs. Let's look at another one. Oh, look, this, ladies and gentlemen, again has two terms, but we know how to do three terms. It's two terms. Let's change it to a three terms trinomial, quadratic. Now, what we have? Three terms. We know how to do that. So, we have our parentheses, and bada bing, bada boom. Ladies and gentlemen, that's it. That is difference of squares. That's how we factor difference of squares. All right, let's look at one more. Now, notice this one has a leading coefficient greater than 1. I make that number so you know it is greater than 1. Now, there's a very nice trick to this. Look at 144, which is the constant. It is a perfect square. Look at the coefficient. It is a perfect square. So we can rewrite it like we've been doing. Now, we know the number that multiplies itself to give us 144 is 12. The number that multiplies itself to give us 16 is 4. And ladies and gentlemen, we know the procedure. Have a parentheses, and the sign is going to be plus and minus, of course. And we have 4w and plus 12, 4w minus 12. That's it, ladies and gentlemen, nothing more. That's it. Now, here's what I would like you to do for me for homework. I want you, instead of me giving you a question to factor in this one, I want you to create 6 questions. 3 questions going to be perfect squared questions. It's like 3 perfect squared expressions. I want you to create them so that they make sense. Now, I'm not going to make this so easy. One of the 3 perfect squared, at least one of them, has to have a leading coefficient more than 1. Better yet, yes, 2 of them has to have a leading coefficient greater than 1. One can have coefficient 1, that's fine. But 2 of them has to have a leading coefficient greater than 1. That's 3 questions of perfect squared, 3 expressions of perfect squared. And you also have to create 3 expressions of difference of squares. At least one of them, in this case, at least one of them must have a leading coefficient greater than 1. But guess what? Here's the cake. You create more questions and they are well done. You get chance of getting extra credit, extra points on your homework, really. All right, let's get to this and enjoy your day.